Hi, everybody. Hope all of you are doing well and staying safe. I'm super excited to see all of you here. Thank you for taking time and joining this session on big data fundamentals and Databricks. Without any further ado, let me introduce you all to the speaker of today, Hrishabh Gupta. So, Hrishabh is a part of enterprise platform team. So, over to you, Hrishabh.
Hey, hi everyone. I'm Rishabh. I'm part of Enterprise Platform team. I'm working as an architect for the team. The team includes Clarity and the IEM part. We are currently developing CDR, and there are other tracks which are going on in Project Symphony. Today's session, I will present the things which are related to. There are some basics vocabularies that are being used in big data world, and how the architecture unfolds for the big data world, and how Databricks is sort of taking a lead in the current world for solving the big data problem. So these are the things that I will be presenting in this particular session. Um, yeah. And shall I start, or should we wait for a couple of more minutes for people to join? Or
Oh, I think Rishabh, you can wait for like 2 minutes and then we can begin.
sure, thanks, Dichita. Yeah, we'll wait for 2 more minutes, guys, and we'll then start.
Okay, so till then we have like a quick announcement to make. So we are setting up a calendar for in-tech sessions in Q2. And if you're somebody who has something interesting to share and would join our sessions as speakers, or if you're somebody who can contribute by giving us topic suggestions, I'm attaching a flyer in the chat box here. So feel free to look at the flyer and drop in your suggestions if you can.
Let me begin. Okay, so so in the today's sessions, I have divided the content into six sections, and will if today's session won't be enough, then I will be covering some of the part in the next session. So the first section that I will be covering with the big data introduction, which will I will tell certain things which are the vocabulary which are being used in big data, which is like what is data lake, what is data warehouse, there are data marts, there are certain fact and dimensions, there are multiple words that are being used in the big data world. And what is the difference between the data lake and data warehouse? Then is the second part is the Databricks product that they always say about that you can have both data lake and the data warehouse as a one single component. So we'll talk about that how the data lakehouse is sort of trying to bridge the gap between the data lake and data warehouse. Then in third section is the how the storage. So in any data world, there are two things that are problems that we are trying to solve together, which is like how efficiently we can store things, and then how efficient that when we are querying that particular data, that we can do it in a very faster way, in a very quicker way. So there's the third section where we will covering that what is the difference between the transactional and the analytical world. Um, the fourth section is about the query engine, the parallel processing that happens in the big data world, and the framework that has been very popular in our like in the recent 10-15 years, which is MapReduce and Spark, that how they sort of works and bring values while sort of reading that and creating analysis out of those big data files. Then the fifth and sixth section are more about that what are the possible optimizations that we can do when we are using the product the Databricks product for our data warehouse solutions as a data warehouse solution. And then third is Snowflake versus Databricks. Those who are already familiar with the reporting platform Clarity, it is currently built on top of Snowflake. It's using Snowflake as a source, as a data source for storing and querying the tables or the big data tables. And now we are migrating toward Databricks. And what are the things which has changed when we are moving from Snowflake to Databricks? Um, so yeah, I'll start with the first section, which is big data introduction. So in back in 2004, Google sort of introduced the map reduce framework, which was based on like it was said like people were dumping their data into a cheaper disk, and then on top of that it built an HDFS, which that distributed file system, and did a parallel processing in each intermediate stage that they used to dump the data within the disk itself, and from there they used to sort of do their big data work. But at that time the big data thing or drawing insights from the data which is getting generated from any uh, uh, from the services that were very limited to big companies. In 2012, almost all industries, like even the small startup, were grown very high. The digitalization took it at a very high pace, and the data growth was almost like exabytes of data was getting generated every day. And the MapReduce and Redshift, like data warehouse solution, became part of each individual industry, almost like every company which has grown, which has passed through 2 3 years in their journey where they have become big. They were using all sort of big data framework to sort of draw insights whatever has been generated out of their system when from their live applications. And the main purpose of so the data that gets generated, this one part which is the transactional in nature, that we build that we have some product which we are selling. But once the product is sold out, to analyze that how the product behavior is there with the users, that then for that it is required that people should sort of collect that particular data, and then from there they can draw insights that and that can make the business even more useful. And then the cycle or the cycle of the business growth keep on happening. uh, then in 2007 17, that Spark becomes popular. It sort of brought a in-memory system to sort of do a data processing. The MapReduce framework was sort of trying to do a lot of fault tolerance, so it sort of was dumping data into the disks. Spark sort of bring a velocity that how quickly you can sort of brought the insights, which the data that is getting produced. And in 2021, Databricks sort of introduces this Lakehouse architecture, which is about integrating both data warehouse and the Lakehouse to be at the same place. We'll talk about the Lakehouse architecture, that what is Lakehouse that Databricks today actually offers. So before that, we'll sort of make you comfortable by the vocabularies that are there when we talk about data. So the data that gets produced, it can be either in the SQL databases, certain types of data which is semi-structured, which is JSON and XML files, or even CSV you can think of as semi-structured because it does not hold that data type information. Uh, okay. Oh, sorry. Okay. Sorry. I thought. One second. Let me just. Uh, is the new screen visible to everyone? Are you,
Yes, yes.
okay. Not okay. So, okay. We'll give a rapid intro about that, what I'm going to cover today. This is like I have divided into 6 sections. One for the introduction about big data, that whatever are the vocabulary that are being used in the big data world. Then there's a Lakehouse product that is being offered by Databricks. That how it is sort of bridging the gap between the data lake and the data warehouse. Then we'll go into a little bit into the architecture of the Lakehouse, that how it is storing certain things and how it is different from the traditional relational database world. The fourth section is about that how the parallel processing is bringing value in the big data world. The Spark, we'll talk about Spark and how the Spark is different from the traditional map reducer, which is the Hadoop map reduce, how it is different from Spark. Then in the fifth section is about the optimization that can we can put in into the system, which can make us the Lakehouse architecture even more efficient. And then the sixth one is about the Snowflake versus Databricks, which is that currently the Clarity team is moving. Earlier we were using Snowflake as a data warehouse solution. Now we are migrating toward Databricks. Then what has changed? What are the results that we sort of learned when we are moving from Snowflake to Databricks? Now, to the first part, we'll quickly cover this part also, that in 2004, Google introduced the MapReduce thing in the big data, like, and that at that time, only big MNC companies was sort of generating the large amount of data. By 2012, there were so many industries, so many companies which were sort of generating the data. The data growth was almost in exabytes per day. Exabyte is something which is 10 raised to power 6 in the terabytes. And that's when this frameworks of big data processing became popular, and almost it became part of any company which is running, which is operating online, which is in the digital world. Everyone, this framework of big data became part of their uh, component. And then in 2017, the Spark came into picture, which sort of enhance the parallel processing from the what the MapReduce was earlier offering. And then in 2021, they come up with a combined solution, that the parallel processing and the schema maintenance. So they created a Lakehouse type of architecture in 2021. So this is the Databricks latest offering, which helps people to manage data in the format of data lake and data warehouse, and then let it query it from there. Then when we talk about the data, generally we divide data into different types. And when we are reading the data, we want to sort of make sure that we can draw insights from every type of data that we are generating. So generally structured data is quite easy sometimes, that the SQL database is there. The semi-structured data, there should be engine which should interpret it JSON and should able to again be making more useful information out of JSON and XML files. Unstructured, even the unstructured data, which is like video, audio, blogs, logs, these are also have become very popular in ML world as well, that when they are processing things, they can do all type of analysis on those words. So they are also, so when we are talking about data, the data that is getting produced, we want to make sure that all type of data we can make it useful for our business growth. Yeah. So now when we talk about the data, so when sort of when any service or any channel sort of dumps the data, when they produce the data, that data is not always in a very good shape, and not and there are many things which can happen across channels. Some channels might be using a different sort of data model, and some might be using a different set of data models, or different type of things that they might be maintaining. And while dumping the data also, they might be dumping in a certain fashion, and with the evaluation they will be correcting the data, and their format might also be evaluating. So data transformation is one of the important aspect of the big data world. So generally there are, we consider, like there are basic transformations which are required when you are dealing with data. That cleaning is a basic one. There's a deduplication, that if the records get pushed twice or multiple times, then that deduplication should also happen. And the key restructuring, there may be like if we want to join the data and we want to make sure that the data is sort of in harmonization, Then the key restructuring, another part of transformation, data transformation work. In the advanced transformation is the derivations. So suppose there are two columns which a particular channel is dumping, like is the total burn that has happened, and then out of it, these are the taxes that has to be subtracted. So probably there may be a pre-compute or at a runtime transformation which might happen, which can tell that what is the actual profit that company has earned, or what is the revenue after subtracting the tax. There may be another thing is the filtering, selecting only which may become important which is more about when people read data, there are different persona and they want to see data in a different bucket. So people, there are certain set of people who will be interested in looking into certain type of columns. So suppose there is a regional AM, then that will probably be interested only looking at the data which is very specific to its own region rather than looking it at a global level. Similarly, there can be certain attributes, like somebody may be interested in just the impression growth and not maybe interested in the rate card part of it. So those type of filtering are also some type of transformation which when we are trying to draw insights out of data, we sort of require. Then there are roll-ups which are like if the data is getting produced in a very raw format, every transaction is getting dumped into the data lake. Then to make it useful as a human, we always look for that how is the daily basis growth that is happening, or a monthly basis the report is happening. Most of the people like looking, it's not in a human capability to aggregate a very terabytes of data in its memory, in its human memory, and then try to sort of draw insight out of it. So aggregations is one of the type of transformation which exists in the data world, that people we that it should provide a capability to do a daily roll-ups, monthly roll-ups, quarterly roll-ups, or maybe the yearly roll-ups as well. Okay, so this is when it comes to the transformation, then the question becomes that how will I transform, how the I will take care of the transformation. So there are two terms which exist in the world, which is the one is the ETL and there is a ELT. The ETL is which is extract, transform, and load, which means that you have received the data. Now you transform it and you sort of store the transform data into your system. The second part is that you just load the data, you just have the data at the runtime, you do the transformation. Now there are both advantages as well as disadvantages aligned with both the approaches, whether you go when you are trying to transform the data, and it's always more like a hybrid approach that any company takes to analyze the data. So generally, so when you think of a ETL, that the transform and load part is happening, which means that you are already pre-computing the transformation. So whenever the transforms are very heavy in nature, suppose you are trying to aggregate the raw data into a hourly level or at a daily level, then that kind of roll-ups and certain type of merging of data enrichment can happen at the time at before you sort of put it into the system in a persistent way. While ELT is good for certain cases, which is like we compute the profit and all. I think. Um, any question from anyone? I'll continue. So this is the second part that like how much you will do the pre-compute. You will not always be able to do all the transformation as a pre-compute. There will be matrices which will still be left, and as your data will grow, you will identify more and more matrices after a certain time, that these are also the certain things which you need to calculate. And there are transformation which can also not happen also at as a pre-compute level. Suppose at a hourly level you compute the total revenue and the total profit. Now the if you want to do the percentage profit, that will happen only at the runtime. It cannot happen at a something at a pre-compute layer, because the value will vary uh, uh, based on the type of roll-up that you are using. It's essentially on the complete set of data only it will be applicable. Now to the problem with ELT is that it may result in a higher latency that one needs to wait for a longer period of time. And there, that's where the materialized view can also become handy. That if the behind the scene, the product that is offering you will take care of the transformation part and keep on caching the things into the materialized view. The ETL can also become as a product thing, but from the engineering point, it will still remain a ELT. It will still remain ETL only, but it can, as a product, it can look like an ELT thing. So yeah, this is the basic difference between ETL and ELT. And there are challenges like in the ELT cases, there are whenever you are thinking of ELT, you will not require sync across different data sets, while in the ETL you will require the sync between the data sets. Like if you are doing a monthly rollups, then you cannot avoid that the last day data is not get generated, and before that you do the monthly rollup, then this will become a data discrepancy in the system. So you need to make sure in the ETL process that your schedule is so that it is taking care of the data in a certain fashion. So ETL comes with its own challenge, ELT comes with its own challenges, and it's up to like we as an engineer sort of decide that at what place what will fit well at different places. Uh, Now we'll come to the
So,
data lake.
Rishabh, one question. So, in general principle, can we say that we are going to use ETL when we are doing real-time processing, let's say in Spark streaming or Apache Storm, and ELT we are going to use when you are doing an operation in batch wise. Let's say we are doing an operation on hourly data or daily data or monthly data.
Correct, that's the right one. So yeah, so there you are right that for the our roll-ups one and the things you will do, or when you are saying about the streaming analytics, okay, they are almost like ETL only, because you are always transforming in the sense if you will not transform, it becomes like that the Spark processing will have to take care about everything, all the transformation at the runtime, and that may impact your performance. So it's about that what is your uh, performance criteria, that if your data is like suppose in only in GBs, okay, then ELT can still be a very good choice. You can say that I will do a roll up at the runtime only, and it's all okay for me. It's not that bad. When the data is used and the performance, you want your business users to sort of expedite that process, that they do not wait, their productivity is not lost. That's where you do the ETL part, that let's do a certain transformation upfront and then put it, make it presentable for the other business people. Okay, and definitely, but the ETL always comes with the sync challenge, that if the particular data set in one format is not right, or there may be a sync issues that the sum across hourly data may not match with the daily data. That is possible because of some failure that might have happened while processing the data. So the sync issue might arise in the ETL. So, but today, like the way Spark works is sort of because it's fault tolerant, sort of recover when trying to process the data. There are very less chances that ETL will sort of result in data discrepancy, but there is still possibility that things can happen. This can go wrong.
Got it.
Sorry, a quick question.
Yeah, sure. Go ahead.
How much impact can have the file format for the ETL process, like regarding XML versus CSV or Parquet file or compress? So how much of an impact can have that through this process? Let's imagine we choose ETL. So from your experience, I guess that's affecting a lot. Can you more or less go through it or have a basic view on it?
So I didn't get the question completely, Francis. Can you repeat
I
like what
just
is?
yes,
Yeah.
yes. So how much of an impact can have the file format, the original file? So you have the main phase, which is extracting the file, and then that will go through the ETL process, the source of the data. So imagine you are storing that. You mentioned before the data can be unstructured or not structured, like a JSON file, a CSV, or it can be a Parquet file, or it can be well, XML or something, or compressed. How much of an impact makes, or how much different makes the how the data is stored in principle?
Yeah, that is actually yeah, that makes a lot of difference. And in the coming section, in the fourth section, we'll cover on that part also, that why that is important, like the raw versus
Okay,
column
okay,
format. And
okay, okay.
we'll cover that part also. But that like to answer is that there's a significant difference that you will sort of get when you are storing something in CSV. You are doing the parallel processing on CSV versus Parquet is a big, huge difference actually. Okay, so we'll cover it
Okay,
in
thanks,
the
Sam. Thanks, thanks,
upcoming
thanks.
section. Yeah, cool. Now there is, like, when you are part of that process where you need to build the data pipelines, or when you need to create a data warehouse, there are two popular terms which are data lake and data warehouse. What is that data lake and what is data warehouse actually are? So generally, data lake is when your data is very raw. You are dumping each and everything there. They are all structured, semi-structured, all type of data is there. And from that data lake, you do all that type of validation. You do the transformations, and the data lake is where whatever data that is there in data lake, for all the data, the purpose might not yet be defined. It's not that useful for the business use case. And the way people think of data lake mainly comes in the fourth point, which is that you dump it everything in a cheaper storage, something like which is Azure Blob or in Azure S3, all sort of all that type of things. And then whatever is required for your developing that insights, only that much of data you sort of curate and process it, and then make it available for your business intelligence team, or for the reporting purpose. There are many things, like to give an example, there may be data which is more like very internal. Suppose to maintain a particular relationship, you have one site ID, and then that is related to publisher ID. Now, for a business user, the site ID is completely a system related concept, or a normalized table is quite a concept which is not relatable to the business. At a over level product, see like a two different nodes which are, while in the engineering there are intermediate three, four tables that might exist. The data lake might be holding more information, but when it comes to reporting, only the certain part of the data which will be required. Same goes for the VI when you are trying to sort of look for the insights. Then, so the data lake is something which holds lot of information, but still there are purpose which people are looking for. It's useful for the data scientists. But if you go to the data warehouse, it's quite cleaned data, and there are data warehouse will have certain tables in a certain number of columns which are very relevant into for the users. The four I am want to emphasize on the fourth point, which is cheap versus vendor dependence. In today's world, when we sort of not thinking about the lake house, the database offering, the thing is that there is a vendor dependence for the data warehouse, because only like we sort of load the data into data warehouse as a RDBMS system itself. So whether how the data will be stored and everything is taken care by the data warehouse offering, like Snowflake is. So we sort of load the data into Snowflake, then Snowflake sort of will do all type of management of the file, that how it will be putting into the its system, will sort of record its schema, will record that what data lies in what place and which table belongs to what particular things. So that is all within the Snowflake system, and when querying the system, that will be you leveraging that work that it has done while writing or dumping the while writing the data into its system. It will leverage that at the query time. So it makes and the data warehouse solutions are quite like, because it is having their proprietary format and all those things, their offerings are generally costlier than than the data that is lying in the storage. So you, if the 1 TB of data that is lying in data lake, and if half of the data I need to transfer to data warehouse, I need to again pay for the 500 GB of data that is that I am going to use for the reporting and the BI purpose. Now that's where there so okay, yeah. So before going on, before moving on to the lake house one, there's another thing that just want to put into like that what vocabulary about the vocabularies. So when you design a data warehouse, how does it look like generally? So there are three particular things which are sort of important or that are there in the big data world. So a fact is nothing that there is a time stamp which says that it's the time where this particular record belongs to. It may be a day, it may be a hour, and then there is then there are country ID, account ID across which you sort of look for the insights. So there may be dimensions which will be lying into separate small tables. They will be probably in few KBs or MBs, but the facts actually sort of holds billions or trillions of records for the like few billions and trillions of records in their system. So facts are that heavy in terms of, we look into in terms of rows, and number of columns are also like will be like 150, 160 type of things. There are another thing other than these dimensions are the measures. The circle that you are saying, that total clicks and total revenue, we see them as a measures, and these are the aggregates that happens on those particular things. And these measures can be of generally they are can be divided into three categories: additive, semi-additive, non-additive. Most of the measures that are useful are additive in nature. There may be few, there are four more information that we need to accumulate while dumping the data, which may be like if there is a sales goal, that probably may be applicable to a certain category only. And summing up it across any other dimension may not make sense and may not be useful. So those are called semi-additive, and there are very less number of example you will find in the semi-additive category, but there are good examples which can be in the non-additive category. Suppose while you are dumping the data, you are dumping that the revenue and the tax percentage, both the things, then that will called as a non-additive thing, because you will not say that the total tax applied is sub can be a sum or can be a average or something like that. It will just be not be useful for any purpose. But when you are trying to say total revenue multiple so one minus tax percentage or something like that, that will give you the actual revenue post taxes. So there it can hold a good information. So those are the things which may be which we sort of define in the tax non-additive measures. So these are this is again the terminology that are more popular in big data world, while in relational data words we do say everything is a tables, and main tables we don't bifurcate it as a fact versus dimensions type of things. But in big data world we sort of define it like which one is holding the most information about the business, the daily business that is happening, like the total clicks, total revenue that I am interested in, they are put in, they are sort of defined as facts. And the dimensions are just for like for a user purpose, that if you want, somebody is looking for a country cut or an account cut or maybe a region cut, then those can becomes more handy and can bring more insights into the for a power for a analytical or the BI user. Now, so in the previous section, it was more like that what are the general terminologies that are being used in big data world. Those are most popular terms when you work with a big data world. These are like part of day-to-day life of any, whether he belongs to a product or a BI team or an engineering team. These are the quite popular terms that are getting used within the whichever team is working on working on the big data part. Okay. Now we'll move to the Lakehouse architecture, that how the Databricks offering is there, like how the Databricks offering of Lakehouse is different from the traditional data warehouse solution, and how they are sort of selling, or they are saying that what is the USP of their product, which is they say there is a Lakehouse or the Delta table, sometimes they say for that. So if you see in the previous slides also, we sort of compared the data warehouse and the data lake, that how the two are different. Generally, what data the data warehouse is holding, what is the data that data lake is holding. Okay, and we sort of also sort of discussed that the generally the data warehouse is a vendor vendor provided products, where we sort of dump the same data again, copy back the relevant data to the vendor's ecosystem, and then sort of try to query it and try to draw insights out of it. The product that Databricks offers, which is using, which they now refer the architecture as data lakehouse, actually is that you can use the data that is lying on your storage. If you will, you can query directly on top of that without sort of putting in additional burden about loading the data into a vendor provided software. So they provided a compute layer, which was earlier also common. But the second part they say is the storage part. When you are dumping data into data lake, let's store it in a certain fashion. Let's keep the information about the data that you are dumping into your storage. Let's maintain a metadata for that. And let my query engine use that metadata and query that data that is relevant for you, so that you don't need to copy, or you do not need to make an extra copy for the data warehouse. So yeah, so that was the main difference that Databricks is bringing in the ecosystem. So the same thing that I earlier was talking, that what changed actually. So there is no separate data warehouse platform that you will be required. Works on the data that was prepared out of ETL. Uh, One can directly query that. You'll see that how that performance part that brings in with using the delta tables is another concept, delta live table, that they have also introduced, which is more like a materialized view. That is so when we talk about materialized view, it's more like how view works is actually that they do the query on the same set of data. But when it comes to the materialized view, you say that whatever data was there, if there were 100 dimensions, and within the view, you try to have just the 10 dimensions, the view will still go and query the data which is big in size. While in the materialized view, it will try to pre-compute that part and will store it on a physical layer so that the performance can be better. It will do that ETL part behind the scene. So that behind, because of it happening behind the scene, it becomes a product which looks something similar to ELT. However, behind the scene, engineering wise, it is still ETL. But as a product offering, it can still say that it is an ELT, because they are taking care of all the roll-ups and everything that has to happen behind the scene. What more it brought in is the transactional support for even for the data lake. Um, when I talk about the transaction support, so earlier when the Spark when Spark used up Hadoop's file writer, and there are two version of the file writer. One is which is sort of uh, follows the this transaction support, but is quite slow in nature. Another is which does not support, but which is fast but does not support the transactions. So the architecture or the product offering that Databricks has come up, they have the transaction support, which means that when you are dumping the data, it will take care of the data which is getting overwritten, so that there is a consistency also. And also while writing, it should not happen that the old data gets deleted but the new data has not been written or flushed to the disk. So that does not happen with the that is another implementation that they have put in within that Lakehouse architecture using the delta tables or the delta format. BI support and so BI support is something which is there's another thing that they have put is that they have provided integration with that Spark SQL endpoint interface that you can go or any what do you say the on any cluster you can use and then it can connect to any Power BI or any Tableau like software. So that adapter also they have sort of built in. It's not for again the ingestion wise or anything wise, that compatibility or adapter is also sort of coming built in with the Lakehouse product or the Databricks product. Then comes the data versioning and the governance part. Data versioning is something which is like suppose a particular data got updated, a particular row got updated. Then if I want to check what was the value in this particular row in the uh, like yesterday, so which is more like if the overhead of the data has happened. Generally, most of the time in the data world, your data is incremental in nature. You always say whatever is the latest value, I will put a latest timestamp on it, and then I will put it into the system. But when the all the pruning happens, everything aggregations and filtering happens. You in their part, you look for if the data is because of some rerun or certain for certain reasons, if the data has changed. In certain cases, that may help in debugging the data. So this feature they have done by doing a soft delete. The soft delete is still maintained by the ecosystem of the Databricks itself. It's not maintained by the storage system that you are having. The soft delete is something like they will maintain that information that which files have been deleted. They will still maintain them within the system, but there will be a metadata information, dedicated metadata uh, information which will say that this particular file is of no use and sort of is something which belongs to the yesterday's version only. So they maintain that every version of the file that is getting there, and the default retention for those is 7 days, but one can change that retention period also.
Hey Rishabh, like I had one doubt on this transaction support for data lake.
Yeah.
Like like one thing is like people say that they support transaction, but like in reality, how good is that? Like for example, I can buy the statement that like MySQL, Postgres, these database they do support transactionality because like the entire process, like the writer and the reader, like whatever, like the writer, everything is like owned by that Postgres or MySQL. But
Correct.
in case of this data lake, the writer is a different process altogether. And writer, like when it is like trying to write the data halfway, just through unseen foreseeable reasons, like that process might die off.
Yeah.
And in that case, like what will happen to the data that is half written?
Yeah, it will still maintain that consistency, Raj. So what they are when they are dumping the data, whenever the successful writing has happened, they sort of make sure that as a commit. They store that commit information, and if the commit has not happened, the reader is actually capable of making a query on the older data itself or the older version of the files.
So in
So
that case, Rishabh, like for all the time, like like let's say I'm updating updating or overwriting the existing data. In that case, like they will at the time of writing, in reality, they'll write to a different place, and during the final commit, they will change the point, the location point to this. Do they do something like this? Because only then it's possible, right?
yes, so under the hood, that is the case. Like whatever, so suppose there is one file, okay, and when you are overriding something, half of the file is only getting written, only half of the records are sort of getting changed. Then they will sort of create a new file and they will start writing to that particular file. They will dump it and they will say in the commit information that use this particular file and mark the old one as a Tom stoned or the soft delete marker. They will put it in the metadata information where they are having this information.
No, actually, like we had a different case recently where instead of one file, let's assume that we had around 300 files. Like for 300 files, like we are trying to write, and like halfway, like it has like the commit that they're trying to change the location, and at that point, like if that the process fails, like what will happen? Like this I agree, it's a rare case, but it actually happened in our CDPA. Like it didn't happen with the data lake, but it happened with the traditional one.
No, that will not happen, Raj here. So even if there are 300 files, the main thing is uh, so the compatibility between the writer and reader is they are bringing it by like the information they are logging. So they are logging that information along with the files when they are writing the files or overriding the files, that what is the when like what are the newer version of those files. If that has not been written, it will not touch the existing files. It will not override or it will not touch the existing files. So the existing system will keep on working until there is a commit timestamp that comes in their metadata information. And the reader will take advantage of that while doing a newer query. That will look for that what is the latest version for this particular file that only I should read while sort of doing a runtime compute.
Fine, Rishabh. Like, yeah, like maybe I'll get in touch with you offline to see like if it really provides, that would be a great thing for like the system that we are trying to build.
Correct. And the same thing that I am saying, the same thing they have used in the data versioning. So the time travel feature of the Snowflake is coming using the same, like you can say from one arrow or like from the same exercise, they are able to achieve the data versioning also using the same mechanism because they are not touching the existing file until it is, and they actually do not touch the files. You can say once the file is written, it is there. Any new transaction will sort of write a new file, and then there will be a commit information that they will put in their dedicated meta store. And while the Spark will be reading it, it will be it will recognize what are the files which are not written, which are sort of active currently in the system.
Oh, okay, Rishabh. Yeah.
Okay, cool. Yeah. Then
Rishabh, just a quick question here. Is there any sort of support? So when you say they maintain some sort of metadata on top of the data that you're storing, is there any sort of support for indexing, or if I'm aware of what my query is going to look like, can I pre-process, build some indexes, any sort of that support? And if that's not the case, my second question was, how does it compare to, let's say, something like Presto, right? In terms of performance and in terms of
Saurabh, like I'm
resources.
not for they have something like Z ordering. With the Z ordering, it is like kind of indexing. Like,
no,
so
so I'll come to that part also. Well, geoordering is one of the thing. So essentially what we want is faster reading, actually, faster processing and unnecessary reading of the data. Avoid unnecessary part of the data. So we'll come to
Correct.
that part in the next section, sort of that how the traditional relational database versus the big data world is little different than maintaining indexes. Okay, and we come to all the
Sure,
reasoning.
sure.
Okay, so we'll cover that part also
Hey,
in next.
Hrishabh, can I make a request? Am I audible, Hrishabh, to you?
Yes, yes, Satyendra. Yeah.
Okay, so just a time check since we have another 10 minutes. Maybe I think we should try to uh, conclude today's session with a logical end, and then I think we can have a follow-up session on some of these uh, interesting questions where you have a perspective which I feel is important for everyone to get and see if that makes sense. So maybe for next 10 minutes, plan your session in a way that we can cover some of the topics and bring this discussion to a logical um, pause.
Yeah, sure, Satya. Yeah, sure. So I'll cover till this like the main the main Lakehouse architecture only, and then about the deep dive into the different part of it, that the storage and the querying part, which are very important from the engineering perspective, how they are different from relational database. we will sort of cover in the next session on the next Wednesday. So yeah, so yeah, I'll cover one more thing with the Lakehouse architecture. So the like a top level view that how any big data word that how the data gets processed. So generally there is a client which you will sort of write a particular job. Then there are Delta Engine and the Spark SQL. They will try to contact the meta store wherever their meta data information is lying, and from there it will sort of orchestrate the different type of jobs that it can run in parallel, and whatever shuffling it has to do, it will prepare a plan and will orchestrate that job, orchestrate all the jobs that it has to carry out in order to build the final data. uh, then it will sort of connect and negotiate with the resource manager, looking at the resource that how many resources are there. This is something which is goes in parallel while preparing the while orchestrating the job as well. And once there is a certain thing that it sort of achieves, it tries to run a parallel processing on the storage, and then everything goes back and the results are generated. So this is a over level, a very helicopter view of the lakehouse architecture or any big data word processing architecture looks something like this only. Even the Presto one is something similar only. Or if you go with the MapReduce or other places, the thing are almost similar in nature. We'll talk about that how Spark is different from Hadoop MapReduce, and how the Delta is bringing more value to the Parquet format in the next session. So this is for today. I guess we are already 4:50, so I'll not go more into the other section. If people are having questions, please feel free to ask, and we can close the today's session, and we'll cover the storage and querying part in the next session.
Yeah, so I had one question regarding the time travel feature, right? So is it, so wanted to know like how is it like working at the metadata layer, in the sense ki does it also depend on the underlying storage also to support such a feature, point in time travel, or is it completely handling via the metadata?
So it's completely handled. So the nothing that like it's not that we that so Databricks ecosystem, or when they the storage can be anything, either it can be AWS S3 or Azure Blob or even the HDFS. Okay, it does not require that storage layer to support some feature, then only they will be able to provide the time travel feature. The soft delete that I am saying is, you can think of is that they are maintaining that information within their metadata information itself. So soft delete, if you go to the same directory and there has a overwritten been done, then you will see all the files as active only in the Azure Blob system, even the ones which are deleted. Okay,
Okay.
so the Delta reader will be capable of reading the data in a in a correct way. Actually, to be precise, if you are using a Parquet reader and using a Delta writer, there are, unless you have not put the retention to be almost zero, where the file will get deleted immediately after overwritten. The data by analyzing the Parquet files will not come as right. It will be having a lot of discrepancy.
Okay, okay.
Rishabh, like I just wanted to know, if I just override the data, how will time travel be even supported? Like if I say spark dot overwrite, like write in that specify the parameter as overwrite, it's not possible, right? In that case.
No, the thing is that when you say spark.write.parquet.over, like then using the option to be override,
Yeah.
then do a that is a Parquet writer. You know? If you are using a
Yeah.
data writer, it is not going to override. It's going to dump a new file and going to maintain that information, which essentially never deletes it immediately.
Okay. Fine.
Okay.
So
You have
it is not there in Parquet, but that thing, that support is there in Delta.
correct, yeah.
Okay, fine.
Hey, hi. If we have like 3-4 years of old data which could be in Parquet or CSV, and we need to now migrate to this new Lakehouse, so is there any easy way, or we'll have to migrate the whole data in Delta format and
Yeah.
use
So
these features?
you are right. If you want to, there are 3-4 years old data that you are having. What makes is possible is even like you can do a override on the same Parquet folders, but essentially it will not give you a much value addition for various reasons, because when the data, when it is proposed by Databricks, it also expects writer to take care of the certain optimization it has to do while writing the data. So that is another part, because if the Parquet files are like even evenly distributed, then certain cases might still work very well. Like the file, just doing the file scanning, they can generate the delta logs. But like when we are migrating from Snowflake to Databricks, we were also having a layer which were in the blob, and like the InMobi has that layer, and from that we were copying it to the Snowflake. So that Parquet layer exists like for many places, and for as a migration we need to convert the entire historical data also into the delta one. We need to use the delta writer to read read, scan, generate stats, put it the meta information, as well as reorganize some of the parts of the Parquet files as well. So there is no easy way. However, the Spark engine will still work. That Spark engine you can still use. So there that Hive table, the Hive store that they are using, you can maintain your Hive tables as well. You can maintain your Delta tables as well.
But again, like let's say in a year or so, another optimized storage comes up and we need to migrate it again. This exercise needs to be done because now we are deeply tied with Delta format.
So I'll come to the Delta format actually. That So what your concern is actually valid, because Delta, so same thing like the time versioning feature, or when overwriting not deleting in actual, they may come as a problem if tomorrow we found that there is a better way or a better format, storage format, then the entire format transformation has to happen. Yeah, so that is that way it's not that extensible, and you are right there. Well, there may be connectors which may people put on top of it, that the new MPP might directly take care of, or also can maintain the delta tables, along with they are also maintaining some XYZ new format as well. But yeah, but if you want to leverage the full-fledged feature, then you will require the migration of the entire historical data into the newer format. So, yeah, there you are right actually.
Hey, Rishabh, one question here. So, when comparing the warehouse versus the lake house, you said that in the warehouse you have to basically keep the data to some. If you have to basically do some quick query, you have to store that data separately, and here you can just build on top of the existing storage, right? And you said that Lakehouse is better in that aspect, better better than warehouse in that sense. So, want to know more on what different aspects is it it is better? Is it um, in aspect of performance? Is it basically developer experience? I can give example. For example, let's say currently, if we have to query a data and some data we require immediately, we keep it in Snowflake, right? And the data which we can wait on, we keep it on SDFS. Now, to basically enable this experience, developer has to write a job to basically copy the data from Blob to Snowflake. And from developer experience point, that's it. So how is it better in uh, Lakehouse?
Yeah.
for yeah.
So there are two things that they are main advantage. One is that one extra hop where you sort of create a files. So whatever you are doing for the HDFS system, if you will organize there itself, you do not need the vendor, like you do not need to push your data again to the vendor machine. So that hop is gone. Okay, so one step in the your data pipeline is reduced. So one task you can say in the entire day is gone, which is about loading from the blog to the vendor provided software. Second part is that what Rajshekhar was also mentioning, because there are asset, because they are maintaining that asset transaction, the delta writer. That's also ensuring you that particular part, that the data is consistent and are not bad in nature. So generally only the data warehouse was supporting that part, and how whatever way they might be sort of maintaining it. But that part also has come back to the lower portion for the data lake itself. So people generally, so that way the third, then what it actually means is that you can have more columns much more quickly. You can add much more columns quickly, or you can do more analysis. You can present while sort of preparing the tables and all other things. So in terms of developer experience or in engineering, the thing is the part that Snowflake was doing at the time of loading the data, that has gone. That is something that has come to the developer. But the easiness, that control has come, that the configuration part is now the writer's responsibility, not the vendor's responsibility. So that part sort of has come as a, you can say it is a cons as well, or as you can say it is a more control as well. Uh, while second part is the cost part, and the having one more step in the data pipeline, that has reduced. So that way it has given a good experience in that way, that it does not require a Snowflake system to dump the like it does not need a data to copy from one place to another.
Have we compared the performance on
Correct. Yeah. So
the
we'll
whole?
cover performance part also. So to give you a quick answer, the Databricks performance was when we write in a very optimized fashion, it was much better than Snowflake. Not much better, but it's decently fair than what Snowflake provides. Our earlier POC didn't give that result, but when the database sort of performed the optimization track, we realized that the data that is coming out of or when we are running the same queries against the Databricks ecosystem, they were running faster than Snowflake.
Okay, got it. Thanks.
Now, this optimization, Rishabh, did they push it down recently, or like earlier, like from the previous thing, what I had heard about was Snowflake was better than Databricks, but these optimization, did they come in recently? Just wanted to know.
So this came in like a last month only. So earlier when we did the POC, we were not aware. When we tried to do all those parts, when we tried to do a POC from our side, we didn't do a due diligence on the other optimization that are available, that are required for making the read queries faster. Okay, so our POC was sort of little not so great, but when Databricks sort of performed it, they sort of put the partitioning as well as the geordering in place. It was running pretty like significant. It was decent faster than the Snowflake one. So the 57 seconds query was running in 23 seconds. There was certain queries which were running 50 seconds in Snowflake were running around 34, 45. All such examples were there. None of the queries which were running for a longer period of time were actually slow in database system. They were all fast. For the smaller ones, we have not yet seen that thing, but we'll look for that also. I guess there also we will be having a good performance only, where the 500 or 200 milliseconds type of performance is there for those short type of queries. We need to do, we have not done that check for now, but for wherever the things were more than 30 seconds or something, there the performance has improved by the Databricks system.
Thanks, Rishabh.
Yeah, cool. Yeah, we are already 5-10 minutes ahead. So yeah, any more question if you have, guys, feel free to ping in the same chat. Happy to answer. I'll paste the PPT also for the rest of the part if you want to do a pre-read before the next session. And in the next session, I will present the rest of the remaining of the part. Cool.
Thanks.
Thank you so much, Rishabh, for a very insightful session. We'll be having a follow-up session next week in the same time, which is 30th of March. Hope to see all of you there, and thank you so much for joining in.